We'll now learn about what is arguably the most useful concept in finance, and that's called the present value. And if you know the present value, then it's very easy to understand the net present value and the discounted cash flow and the internal rate of return, and we'll eventually learn all of those things. But the present value, what does that mean? Present value. So let's do a little exercise. I could pay you $100 today, so let's say today I could pay you $100, or, and it's up to you, or in 1 year, I will pay you, I don't know, let's say in a year I agree to pay you $110. And my question to you, and this is a fundamental question of finance, everything will build upon this, is which one would you prefer? And this is guaranteed. I guarantee you, I'm either going to pay you $100 today, and there's no risk, even if I get hit by a truck or whatever, this is going to happen. The U.S. government, if the earth exists, we will pay you $110 in 1 year. It is guaranteed, so there's no risk here. So it's just a notion of you're definitely going to get $100 today in your hand, or you're definitely going to get $110 1 year from now. So how do you compare the two? And this is where present value comes in. What if there were a way to say, well, what is $110, a guaranteed $110 in the future? What if there were a way to say, how much is that worth today? How much is that worth in today's terms? So let's do a little thought experiment. Let's say that you could put money in let's say you could put money in the bank, and these days banks are kind of risky, but let's say you could put it in the safest bank in the world. Let's say you, although someone would debate, you put it in government treasuries, which are considered risk safe because risk free, because the U.S. government, the Treasury, can always indirectly print more money. We'll one day do a whole thing on the money supply, but at the end of the day, the U.S. government has the rights on the printing press, etc. It's more complicated than that, but for those purposes, we assume that a U.S. Treasury, which essentially is you're lending money to the U.S. government, that it's risk free. So let's say that you could lend money. Let's say today I could give you $100, and that you could invest it at 5% risk free. So you could invest it 5% risk free. And then in a year from now, how much would that be worth in a year? That would be worth $105 in 1 year. Actually, let me write the $110 over here. Right? So this was a good way of thinking about it. You're like, okay, instead of taking the money from Sal a year from now and getting $110, if I were to take the $100 today and put it in something risk-free, in a year I would have $105. So assuming I don't have to spend the money today, this is a better situation to be in, right? If I take the money today and risk-free invest it at 5%, I'm going to end up with $105 in a year. Instead, if you just tell me, Sal, just give me the money in a year, give me $110, you're going to end up with more money in a year, right? You're going to end up with $110. And that is actually the right way to think about it. And remember, everything, and I keep saying it over and over again, everything I'm talking about, it's critical that we're talking about risk-free. Once you introduce risk, then we have to start introducing different interest rates and probabilities, and we'll get to that eventually. But I want to just give the purest example right now. So, already you've made the decision, but we still don't know what present value was. So to some degree, when you took this $100 and you said, well, if I lend it to the government, or if I lend it to a risk-free bank at 5%, in a year they'll give me $105. This $105 is a way of saying, what is the 1 year value of $100 today, right? What is a 1 year out value of $100 today? So what if we wanted to go in the other direction? If we have a certain amount of money and we want to figure out today's value, what could we do? Well, to go from here to here, what did we do? We essentially took $100. We took $100 and we multiplied by, what did we multiply by? 1 plus 5%. So that's 1.05. So to go the other way, to say how much money, if I were to grow it by 5%, would end up being $110, we'll just divide by 1.05. And then we will get the present value, and the notation is PV. We'll get the present value of $110 a year from now. So 110 year from now. Year from now. So the present value of $110 in, let's say, in 2009. It's currently 2008. I don't know what year you're watching this video in. Hopefully people will be watching this in the next millennia. But the present value of $110 in 2009, assuming right now is 2008, a year from now, is equal to $110 divided by 1.05, which is equal to, and let's take out this calculator, which is probably overkill for this problem. Let me clear everything. Okay, so I want to do 110 divided by 1.05 is equal to 104 point, let's just round, 0.76. So it equals $104.76. So the present value of $110 a year from now, if we assume that we could invest money risk-free at 5% if we were to get it today, the present value of that is, let me do it in a different color just to fight the monotony. The present value is equal to $104.76. Another way to kind of just talk about this is to get the present value of $10 a year from now, we discounted the value by a discount rate. And the discount rate is this. Right here we grew the money by, you could say, I don't know, our yield, a 5% yield, or our interest. Here we're discounting the money because we're going backwards in time. We're going from a year out to the present. And so this is our yield. To compound the amount of money we invest, we multiply the amount we invest times 1 plus the yield. Then to discount money in the future to the present, we divide it by 1 plus the discount rate. So this is a 5% discount rate. 5% discount rate to get its present value. So what does this tell us? This tells us if someone's willing to pay $110, assuming this 5%, remember this is a critical assumption. This tells us that if I tell you I'm willing to pay you $110 a year from now, and you could get 5%, so you could kind of say that 5% is your discount rate, risk-free, that you should be willing to take today's money if today I'm willing to give you more than the present value. So if this comparison were, let me clear all of this, or let me just scroll down. So let's say that 1 year, so today, 1 year. So we figured out that $110 a year from now, its present value is equal to, so the present value of that 110 is equal to $104.76. So, and that's because I used a 5% discount rate, and that's a key assumption. But what this tells you is, this is a dollar sign, I know it's hard to read. What this tells you is that if your choice was between $110 a year from now and $100 today, you should take the $110 a year from now. Why is that? Because its present value is worth more than 100. However, if I were to offer you $110 a year from now or $105 today, the $105 today would be the better choice. Because its present value, right, $105 today, you don't have to discount it. It's today. Its present value is itself. $105 today is worth more than the present value of 110, which is $104.76. Another way to think about it is, I could take this $105 at the bank, get, let's assume I have a risk-free bank, get 5% on it, and then I would have, what would I end up with? I would end up with 105 times 1.05 is equal to $110 and a quarter. So a year from now, I'd be better off by a quarter. And I have the joy of being able to touch my money for a year, which is hard to quantify, so we leave it out of the equation. Anyway, I'll see you in the next video.